and Sunday for lunchtime, they made a total of 146 sandwiches this past weekend. On Saturday, the special was American Sandwich. Sunday special was a club. Here's a breakdown of the logistics of their sandwich making. They made 12 ham sandwiches on Saturday and 10 on Sunday. On Saturday, they also made 55 American sandwiches and 6 club sandwiches. While on Sunday, they made 60 club sandwiches and only 3 American sandwiches. Every sandwich requires 2 slices of bread, cheese, mayonnaise. The ham sandwich has ham as its only meat. The American has turkey and roast beef, and the club has ham, turkey, and roast beef. Looking at just the paragraph form, how many club sandwiches do they make on Saturday and Sunday? No, club sandwiches.
66.
Just club sandwiches.
66.
On what day?
Saturday and Sunday.
66.
Okay, 66, they say. I don't know the answer. But is it easy to see? Is it easy to pull that information out of our paragraph?
Oh, no.
No, it's not really easy to see. So why matrices? Why matrices? Now let me ask you the same question. How many club sandwiches did they make on Saturday and Sunday combined?
66.
A lot easier to see using this organized information here. We call this a matrix, right? We did some matrices last week. Lot easier to see. So number 1, which form of presentation of Devontae's Daily Delights do you prefer? The paragraph form or the matrix form? You need to write that answer down on your paper. Because my answer might be different than your answer. Your answer might be different than everybody else's answer. And it does ask you to explain why you prefer that form over the other. It does ask you to explain why you prefer that form over the other form. So matrices are pretty useful in organizing large amounts of data. We only have Saturday and Sunday. What if this sandwich shop was open 7 days a week and we had to put all of that in paragraph form? How much longer would our paragraph be? A lot longer. What if we had more than 3? What if we had 6 sandwiches? Not just 3 sandwiches, but 6. How hard would that be to organize in paragraph form? It's going to be really hard to start pulling that information out of those paragraphs. But using our matrices here, it's going to be easier to see those things, especially if we're open more days a week, if we have more types of sandwiches. All right, number 2. I'll give you, let's say about 10 seconds maybe. For number 2, how many slices of bread are needed on Saturday? Just Saturday. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. If you didn't get an answer, that's okay. I'm trying to prove a point here, right? I'm trying to prove a point. It's going to take you a minute to do those calculations, perhaps. Number 2 might be a little bit easier than number 3, though. Over the entire weekend, what do we need more of? Do we need more ham? Or do we need more roast beef? 10, 9, 8. Are we guessing or do we know?
Isn't it the same amount?
Ham is bigger number.
I can't even think.
8, 7. I'm trying to prove a point here. Trying to prove a point here. All right. Maybe you came up with an answer. Maybe not. Let's move on to number 4. Over the weekend, what meat do we need the most of? What meat did we need the most of over the weekend? 10, 9, 8, 7, 6, 5, 4, 3, 2. I'm trying to prove a point. You're like, I didn't have time to do that. But watch what's going to happen in just a second. We're going to come back and we're going to answer questions 2, 3, and 4. And it's going to take you like 2 seconds. I promise. I promise. 2 seconds. What if there was a way?
That's right.
What if there was a way we could make a third matrix that included all that information that we need? Maybe a third matrix that told me how many slices of bread I needed on Saturday. Maybe a third matrix that told me how much ham and roast beef I needed on Saturday and Sunday. Maybe that exists. Last week we talked about multiplying matrices without context. We just multiplied them, just numbers. Now we have context. Number 5. We're going to multiply these two matrices together. But remember on Thursday last week and Friday last week, we said, hey, the order that we actually multiply matrices matter. If I take a matrix A and a matrix B and I do A times B, is that going to equal B times A?
No.
No, we said no. And we even wrote down a law, basically, this big rule that said, hey, matrix multiplication is not commutative. We talked about that last week. So in number 5, if we wanted to multiply these two matrices together, would we do the ingredient matrix times the order matrix? Or would we do the order matrix times the ingredient matrix, and why? Which order should we multiply these two matrices together? And does it matter?
I think we should do the days first.
It does matter. Cash thinks we should do the order matrix first. He said the days. I'm assuming that's what he meant, the order matrix. He thinks we should do the order matrix first. Why, Cash? Any explanation of why we might need to do the order matrix on the left and the ingredient matrix on the right?
Like it is
Lucky guess. Maybe it's not even lucky.
already on the left.
It's already on the left. Well, I might do that to try to trick you, right? Maybe we don't want it on the left. Maybe we actually want to put it on the right.
I say you ingredients first.
Ingredients first. Doesn't matter.
I think you should do ingredients
Yeah, I think
first, that way you can see how many ingredients you used on each sandwich on the.
That way, how many ingredients we use on each
That
sandwich,
way it's
okay?
like background
Okay, I'm
knowledge
listening.
of the sandwich.
All right, here's how we know whether we're going to, which one we're gonna multiply first. And ultimately, it doesn't matter. I'll show you in a little bit. It doesn't matter how we set up our matrices, but the way they have their rows and columns set up, if we're gonna take this matrix and this matrix, and we're gonna multiply them the way they're set up,
Oh, I know.
without changing the rows and the columns, here's what we have to do. The columns of the first matrix not only have to be the same number, but the category of each column has to match the rows on the second matrix.
It's the only way it works.
The only way it works. The categories for the first matrix, not only do you have to have the same number of them, they have to line up. Ham, club, American. Ham, American, club, rather. They have to match. That's the only way we can multiply this. So when we multiply, we're going to do the order matrix times the ingredient matrix. Why? Because the columns have to match the rows. The columns of the first matrix have to match the rows of the second matrix. And how are we going to multiply these together? Today, we're going to use matrix technology to help us multiply them. So at this point, you can get a laptop or you can get your phone out, and we're going to use Desmos. But when you use Desmos, you cannot use the normal Desmos that you're used to. You can't go to the Desmos graphing calculator and find a matrix on there. There's not one. You actually got to go to desmos.com/matrix, and it's going to be its new website. Some of you are going to ask me later, like, how do I get to this? How do I pull up a matrix? You can't pull up a matrix on the Desmos that we normally use. Desmos.com/matrix. Are there more websites that we can use? Yeah, there is, but this is the one we're going to use. And when you type it in, it should look something like this.
It just says new matrix.
Yeah, it says new
It
matrix,
looks like on
so
the board attached.
we're gonna create a new matrix. So click on that, new matrix button. Our first matrix is gonna be the order matrix. We want a 2x3 matrix, so we can change the number of rows, number of columns pretty easily. We just want a 2x3 or a 3x2, whatever we want. We want a 2x3 in this case. And we're gonna type in on Saturday, we sold 12 ham sandwiches, 55 American sandwiches, and 6 club sandwiches. And on Sunday, we sold 10 ham sandwiches, 3 American sandwiches, and 60 club sandwiches. And then we're just gonna hit enter. So it didn't really do anything to it. It's just storing that information in matrix A.
What do we do?
Just enter, or this button down here, it looks like this arrow, the return button. And now we want a second matrix. So we're gonna hit new matrix again. And we're gonna type in our ingredient matrix this time. It is 3 rows and 6 columns. And what does that ingredient matrix tell us? We haven't talked a whole lot about it, but it tells me that on the ham sandwich, there's 2 pieces of bread, 1 slice of cheese, 1 serving of mayo, 1 serving of ham, and no turkey and no roast beef. And then on the American sandwich, there's 2 pieces of bread, 1 piece of cheese, 1 serving of mayo, no ham, 1 serving of turkey, and 1 serving of roast beef. And then on the club, there's 2 slices of bread, 1 serving of cheese, 1 serving of mayonnaise, 1 serving of ham, 1 serving of turkey, and 1 serving of roast beef. So I'm trying to prove a point. How long did it take you to do 2, 3, and 4 earlier? Too long, right? I didn't give you enough time. You're like, man, you took too long. Y'all should have did that quicker. Watch how fast it's going to take when we multiply these 2 matrices together, and then we go back and answer number 2, number 3, and number
Could have
4.
done this the whole time last week.
So I'm going to hit enter. All we're going to do, we have matrix A, which Desmos automatically names them for us. We can't
It's
change
A
the name.
times B.
A times B. And we got this new matrix. This third matrix that might give me a lot of information. And let's just write this matrix down in number 6 on our notes today. Let's just write this matrix down in number 6 on our notes today. Then we'll talk about what it means. So just copy it over, if you will. Uh, 18, 61, 61. All right, so it's cool that we found this new matrix, but if we don't know what this new matrix means and represents, it doesn't do us any good to even find it. So, very specifically, what does the first row represent?
Saturday.
The first row is Saturday. That is good. What does the second row represent? Sunday. It really helps to label these things. What would the first column represent? Bread. What about the second column? Cheese. Third column? Mayo. And then we got ham, turkey, and roast beef. Now, let's go answer number 2. Let's go back and answer number 2, number 3, and number 4. Number 2, how many slices of bread are needed on Saturday?
142 left.
Man, 10 seconds, was 10 seconds long enough earlier?
Yeah.
Probably not. But if I have this matrix, is 10 seconds long enough? Yeah, absolutely. So we needed 146 slices of bread on Saturday. So you can go back and answer number 2 now. I didn't get, we could have figured that out, but how long would it have taken to figure that out? And that would have only figured out 1 element of that matrix. All right, the other question, number 3. What do we need more of? Ham or roast beef? We need more roast beef. How many sandwiches did we sell that had ham on it? 18 plus 70, 88. How many sandwiches did we sell that had roast beef on it? 124. We figured that out pretty easily once we did the matrix multiplication. And then whatever other number 4, which meat did we need the most of? Roast beef and turkey were actually tied. We sold 124 sandwiches that had turkey and roast beef on it. All right, just a few more like specific questions about the matrix that we just found. It says, what is D11? It said to call this matrix. This is matrix D, by the way, capital D. That's matrix D. So what would D11? What element in matrix D is in the first row, first column? What number is that? 146. What does that represent? Just to be a little bit more specific. We've already labeled it, so we probably already know what that means. But that's how much bread we use on Saturday. Bread on Saturday. All right, cool. Number 8. What's D14 and D24? And what do those numbers tell us? The first row, the fourth column, and the second row, and the fourth column. 18 and 70. What does that tell us?
Ham on Saturday and ham on Sunday.
Good. So 18 is how much ham we needed on Saturday, and 70 is how much ham we needed on Sunday. Now, our matrix was kind of small, right? We only had 3 sandwiches, we only had 2 days, we only had 6 ingredients. What would this look like if we went up to Subway? Probably a lot more, right? What would this look like if we went up to Oink Joint? How many plates does Oink Joint serve that have barbecue on it? Barbecue taco. Maybe it's like a half of a serving of barbecue. Maybe you can get a barbecue plate with extra barbecue. So now maybe we're getting like 1.5 servings of barbecue on that barbecue plate. Maybe we got a barbecue sandwich that only has 1 serving of barbecue on it. So then we could do the same thing at any restaurant, really, not just a sandwich shop. Number 9, where have you seen D14, D24 before? You have not seen those yet because I didn't give you time. But had I given you time, you would have found these in number 3. But I didn't give you time to find them, okay? Because I knew, like, why would we waste our time finding them if the matrix multiplication is going to give me all of that information anyway, very clearly and very organized for us. And number 10, for this particular situation, what does each element of this matrix represent?
An ingredient on Saturday.
The amount of ingredients we needed on each day, or on that day, I guess. The amount of each ingredient needed on that day. The amount of each ingredient needed on that day, whether it be Saturday or Sunday.
Are we gonna work this over this before break?
You have a quiz on Wednesday, yes. That is correct.
Wait, with Desmos or without it?
Half will be without Desmos, like you did on Friday. And the other half will be with Desmos, like yesterday, or like today. All right, last problem we're gonna do together today. Maybe not. Let's just do add file, please. Print out 1, 3. Right there. Please work. Oh, it worked that time. Maybe. All right. This question right here. What if they don't give you the matrix? Like, they didn't give us a matrix here. We got a situation where we got a middle school and a high school have an inventory list. They ordered all of this stuff. They ordered sweatshirts, t-shirts, and pennants that they're gonna sell at like the spirit store or whatever, maybe like up in the concession stand at lunch, you can go buy these things, right? They had 61 sweatshirts, 63 and 74 left over. The high school had that many left over. And we wanna figure out the inventory cost, like how much cost is wrapped up in the inventory that they have remaining at these two school stores. What can we do? Well, we need to use some matrices. And these matrices are gonna be kind of small, but we can always make them bigger. Maybe instead of just middle school, high school, maybe we have elementary school, primary school, ninth grade academy, pre-K building, right? Maybe we have the football stadium. Maybe we have the baseball stadium. Maybe we have the gymnasium. All of those different places where we could also sell these same things. And maybe we sell more than just 3 things. Maybe we sell 10 things. So these matrices are gonna get a lot bigger. So how might I set my matrix up so that I can actually perform the multiplication? I don't wanna just go in here and just start putting numbers in a matrix. I need to think this through, because if I set up my matrix and then I set up my second matrix and the columns don't match the rows, the multiplication's not going to happen anyway. So I need to make sure the columns match the rows. So what can we do here? Maybe let's label the columns, and maybe let's label the rows before I even try to put numbers on it. So what might we label those columns? I'll put 3. 3 is arbitrary. I might have to erase one or add one.
Sweatshirt, t-shirt.
Yeah, we might put sweatshirt, t-shirt, pennant. Sweatshirt, t-shirt, pennant. Those are the same. Now I can do my multiplication. Now, does it matter if we put the price on the left or the inventory on the left? No, it doesn't really. I can put the price on the left, the inventory on the right. I can put the inventory on the left or the price on the right. It doesn't really matter. I'm going to, because I've done it the same way all day, I'm going to put the inventory on the left. But you absolutely could have put the price on the left and then put the inventory on the other side in the other matrix. So sweatshirts, we had 61, we had 63, and we had 74. High school, we had 58, we had 71, and we had 92. And the price of those, the sweatshirt was $15, the t-shirt was $9, and the pennant was $5. We can perform this calculation using the Desmos matrix calculator. If you want to use A and B again, you're going to have to delete A and B. But if you just hit new matrix, we can use matrix C, a 2x3 matrix. A 2x3 matrix that has our inventory, which is 61, 63, and 74, and 58 for the high school, 71 t-shirts, and 92 pennants at the high school. And then matrix D would be our cost matrix. It's going to be 1 row, and I'm sorry, it's going to be 3 rows and 1 column, 15, 9, and 5. And then we can multiply C times D. So the $1,852, that's how much money they have spent in inventory that is still at the middle school. Like, they haven't sold that yet. That's the way I understand this question. We haven't sold this yet. It's still in our inventory. And then at the high school, we have $1,969 worth of stuff left in our inventory at the high school. And then the last question on there, we've kind of already answered that question before about the ticket prices. Attendance for the first 3 football games. I'm not actually going to work this one out completely, but let's talk about how do we multiply? Like number 4. What if I did this in number 4? Let's use this for the first matrix, right? And what if I made my second matrix where adults went right here, adults, and then students went over here. Adults is $5, students is $2.50. Is that multiplication possible?
Yeah.
No, it's not. Why is that multiplication on the board not possible?
They're not on my opposite sides.
They're not on like opposite sides, something like that, maybe. The columns
Oh.
does not equal the rows. What's the row? The row here is actually price. Does adult and students and price match up?
I wrote it different, that's why.
Those are not the same thing. I'm talking about the way I wrote it though. Maybe you did write it differently. And maybe you did write it the correct way, but I'm trying to show you like, we can't just start writing stuff down and expect it to work, because it's not gonna work, because adult and students and price, those aren't the same. I need adult and students over here. Okay, let's erase this. Let's erase that. What if I tried something else? What if I did make it, something like this? What if we put the students on top and the adults on bottom?
No.
$2.50, and $5.
I don't think that would work. No.
Is that going to work? No, because when I start multiplying, what's gonna happen? I'm gonna multiply the adults times the student price and the students times the adult price. That's not gonna work. Well, what if I tried to, what if we tried to put this matrix on the left side? Maybe I want this one to be on the right. Maybe I want that matrix to be on the right, and I'm gonna put another matrix over here on the left. How would I set that matrix up?
Adults and students.
Maybe I want to put the price matrix on the left. What could I do to set that up?
Adults on the left, adult top.
Adults.
Yeah. and
Well, here's what's gotta
students-
happen. Here's what's gotta happen. Since this is game 1, game 2, game 3, what's the only way I can multiply a matrix on the left? This has to be game 1, game 2, game 3.
Obviously.
Is that possible? That's not possible. Because all I know is adults, children, and price. I don't know anything about game 1, game 2, game 3. The prices aren't changing from game 1, game 2, game 3. So this is actually, I can't do that the way it's set up. I could rearrange this, and I could put the adult students over here and put the game 1, game 2, game 3 up here. This is possible. I'm just showing you like all the different ways that we can set this up and actually not be able to multiply it. Could we multiply it? Yeah. This has got to be adults. This has got to be students. So the numbers are cool. The multiplication's great. But if we don't set up the two matrices correctly so they can be multiplied correctly together, it doesn't matter what else happens. If I don't set them up correctly, maybe you could multiply them, but is it going to make sense to multiply them? Probably not. Probably not. Your classwork today is likely your classwork tomorrow also. And then your quiz is on Wednesday. I will not see you guys on Thursday or Friday.